Hey everyone, welcome back to Better Biomed. I was over at some hospitals today and I was told a story by one of the technicians that made me really think, because this is the kind of thing that could throw anybody off, even on your best day, and it's when you're dealing with 220 volts. So here I am out in the Texas heat, standing here with my fuse panel over my head so that I can get you guys a better idea of what happened and how to look out for maybe this similar situation on equipment in your future. Alright guys, so this is my poorly labeled and extremely old fuse panel. Yes, I know I have to change this out. It's going to happen sometime. But there's a couple of these breakers in here that you should be aware of. You see them right here, right here, right here, and right here. Notice how they have a bar that turns them into a union. See that? There's a metal peg that turns them into a 220 volt union. So if you think about electricity in the United States, we get 220 volts by taking 120 volts from each leg of a split phase system. You know, the difference in potential is going to be 220 volts. So let's say that you get a dryer. In this particular instance, that's exactly what happened. There was a dryer that was installed at a house, and when they wired it up, the control panel turned on. It looked fantastic. Everything seemed hunky-dory until they tried to run it, and the machine would not heat up. Now this is the kind of thing that would throw anybody, because you would assume that if you have electricity, that it should run. And the first place I would probably start checking, if it didn't heat up and I had a control panel and it looked like it was turned on, first place I would check is the thermal fuse and check the heating element, right? Because things do get damaged in transit. But what if I told you the thermal fuse had absolutely nothing to do with this resolution? So the interesting thing is since you have 120 volts and 120 volts on a split phase system, and together they make the 240 volts here in the United States, electric dryers require 240 volts. However, if you have one leg that is active and the other leg is not active, it is entirely possible, if it's the correct leg and it's connected to the DC power supply, that you will have power on your control panel, because only one leg is going to be connected to the internal switch mode power supply that's providing DC to the control panel. Only one leg. So if the other leg is out, that means you only have 120 volts to your 220 volt electric dryer. A really odd situation, and come to think of it, I've seen this before. So what happened is the union that I showed you that's between those two circuit breakers, on his particular unit, one of them was tripped and the other one was not. Well, if that union is loose and sloppy, that's what will happen. They're designed to trip together, just like they're designed to be activated together. And as you know, the only way to reset those breakers is to shut them all the way off and turn them back on as a union, as a junction, and now you have your 220 volts. Well, in his, one of them would trip and one of them was active. And if it was a weak breaker, which does happen, then the only way to change that solution is to change out the whole breaker. You have to change out the whole thing. And that's what he'd ended up doing. So I actually have seen a similar situation probably about 15 or so years ago. I had a 3-phase ultrasonic cleaner, and it acted like it was turned on, but it had a severe dump of power. It just would not output anywhere close to what it was supposed to. And come to find out, that 3-phase ultrasonic cleaner, it lost one of its phases, and that was over in Germany. But it was a beast, an absolute beast, and it was a slight antique, but it used 3-phase incoming power, and it powered all those transducers. But somehow like every other transducer or something was on this other leg, and that is what actually killed its potential, is because if you don't have every single transducer active, it kind of acts like a dampener, you know, the fluid that's inside the ultrasonic washer, and if they're not all cavitating, then one of the fluid that's not cavitating is going to dampen out the waves of the other one, and it's going to feel like it's extremely low power. So guys, anytime you have 220 volt, just because you have power on the device does not mean that you have both legs. Remember, always measure from each terminal of the leg to ground. And that should always be 120 volts. So you should have 120 volts, 120 volts, and ground to neutral bus bar, depending on your 220 volt system. Sometimes you have a neutral, sometimes you don't. It just depends on your particular configuration. All right, guys, that's my little tidbit for today. Just remember, if you have 220 volts, always measure each leg. Do not be fooled just because you have power on your display. Remember, all it takes is one leg, and it steals a little bit of power to power up a switch mode power supply, and that's how you have DC to power the control panel and everything. There you have it. All right, guys, thanks for watching. Check your 220 volt correctly.